Dear students, in our previous video we have been discuss and derive the Newton's second law of motion. In today's video or virtual class, we will discuss about some applications of Newton's second law of motion. After that, we will discuss about the Newton's third law of motion and its applications. So right now we will start with the applications of Newton's second law of motion. As we have seen, Newton's second law quantitatively define the force. It's give the exact magnitude of the force which we may obtain, we can calculate by the second law. What are these? What are the uses? What are the applications of Newton's second law, which we see in our surroundings? Some observations in our daily life which are based on Newton's second law. First of all, catching a cricket ball. A cricketer moves his hand backward while catching a fast coming cricket ball or fast moving cricket ball. Why he draw his hand back while catching? The reason is that it's increase the time of catching, which resulted in less momentum. If he suddenly try to catch a fast moving ball, the rate of change of momentum is very high in a very short span of time. That may lead to injury, and there is a greater chance to slipping of the ball or catch may miss. But pulling his hand backward while catching the ball, this action helped to reduce the fast moving ball momentum more gently, exert less force on his hand, and hence prevent injury of his hands. Second, we see in case of athletics players, either it is a high jump or long jump. During athletic meet, a high jumping athlete is provided either with a cushion or a heap of sand on the ground to fall upon. This cushion or sand, being soft, reduce the athletics momentum more gently and prevent him from injury. Today we see most of the cars are coming with seat belts. According to law, it is mandatory for the drivers of the vehicles, driver of the car, or the passengers seated in the car to use their seat belt. What this seat belt does? This is based on the principle of Newton's second law of motion. These days, all the cars provided with seat belts for passenger to prevent injury in case of accident. Fast moving car stops suddenly due to this. A large momentum is reduced to zero in a very short span of time. The slightly stretchable seat belts worn by the passenger of the car increase the time taken by the passenger to fall forward in case of accident. Due to the longer time, the rate of change of momentum of passenger is reduced and hence less stopping force acts on them. So the passenger may either not get injured or may get less injury. These are the common examples based on the Newton's second law of motion. Now we will discuss about the Newton's third law of motion. You also observe in your surroundings when ball, either it is a handball or football, when it strikes to the surface of the earth, greater the force applied on it. In a reaction, it also jumps higher. That means when a body exerts a force on the surface, whether it may be ball or anything, the surface also exerts an equal and opposite force on the body. This is the central idea of the Newton's third law, which can be stated as follows. To every action, there is equal and opposite reaction. This is the statement of the third law. For every action, there is equal and opposite reaction. Action and reaction acts on two different bodies, but they act simultaneously. By example, we will illustrate Newton's third law of motion. First example is our walking. How do we walk? In walking, we apply a force on the earth. In reaction, we apply a force on the earth in backward direction. In its reaction, earth also apply a equal amount of force in forward direction, in opposite direction, which propel us forward. By that we are moving. Though action and reaction are equal in magnitude, they don't produce equal acceleration. They are having equal magnitude. Action reaction forces are having equal magnitude, but their consequence may be separate. Acceleration produced will be more in the body having less mass, whereas acceleration produced will be less in the body having more mass. A recoil of guns. When a bullet is fired from the gun, the force sending the bullet forward with a very higher speed. At the same time, gun gives a jerk in backward direction. Due to higher mass of gun, its velocity is less in comparison to the fast moving bullet. This is called recoil velocity. Flying of aeroplanes and rockets is also based on the Newton's third law of motion. The jet aeroplane engine exert backward force on the exhaust gases produced by the burning of fuels. The backward rushing exhaust gases exerts forward force on the engine, which make the jet move forward or the rocket move forward. In case of boat or ship, in case of boat or ship, when we jump out of ship, on the bank of a river or lake, the boat move in backward direction. This also shows the action and reaction. When we are sailing a boat, we apply with a log, we apply a backward force with the help of a log in backward direction. In its backward force, there is a opposite reaction which propel the boat in forward direction. Greater the force applied in the backward direction, greater the speed of the boat in the forward direction. Swimming may be also an example of which is based on Newton's third law of motion. A swimmer with his palm or hands apply the force on water in the backward direction. In its reaction, water apply a force which propel him in forward direction. Okay, now we have finished all three laws, their statement and their applications, uses. In our next video, we will discuss about the conservation of momentum or linear conservation of momentum. Thank you.